A very good morning, dear students. Myself, Dr. Debo Vasenbat Vijakshin, Assistant Professor, Department of Mechanical Engineering, SRMPRC Engineering College, Kochi. So I'm going to take topics in fluid mechanics. The topics to be discussed in this session is energy losses in pipelines. And second, types of energy losses, loss function in flow through circular conduits, and Moody Diagram. So these topics are under the category of Unit 2, that is flow through circular conduits. The energy losses are the major problem nowadays in fluid flow, in mostly in the energy sectors. So they have faced a lot of problems regarding this energy losses, either major energy loss or minor energy loss. So we are going to discuss the topics now in this. So what are the losses in pipeline? What are the various energy losses in pipeline? The first one, major energy loss. Major energy loss. And another one is minor energy loss. Major energy loss means loss due to friction, pipe friction. So friction in the sense, friction between the pipeline surface and the fluid medium. The major losses occur due to friction within a pipe. The Darcy-Weisbach equation used for calculating the major loss. In minor loss, loss due to the various changes in section, attachments, the pipe fittings, due to sudden extraction, contraction, due to pipe bend, inlet and exit, some changes in pipe structure or the flow of pipe structure that will affect the flow. So that is called minor energy loss. Yeah, here the total head loss is the summation of major loss and minor loss due to wall friction. So there's this formula. See the slide. F L V square by D into 2G. Here F is a friction factor, L is a length, and diameter, velocity gradient V square by 2G. So here the friction factor for various pipes that is we are find out by using the formulas and by using the Moody diagram. Due to sudden expansion, contraction, so we can use the formula K into V square by 2H. So coefficient, that is the contraction coefficient, it may be expansion coefficient or pipe fitting coefficient, etc. So major losses due to this friction, and the minor loss, already I say that losses occur at the change of section, wall, bend, or some other interruption. The Reynolds number and relative roughness. These two things are very important find outs during the flow rate, during the friction head losses, especially in the major loss. The major loss is determined by the Darcy's formula. So HF is equal to FLV square by D into 2G. So if it's a friction factor, already I have said that diameter, length, velocity gradient. If the Reynolds number is 2000 below, means the flow will be considered as laminar. If it is more than 2000 means the flow will be considered as turbulent. So the relative roughness and Reynolds number plays a major role. So based on the values of roughness and Reynolds number, the friction coefficient will be decided. So friction coefficient or friction factor that we are calculating by the formulas for different flows, laminar flow, turbulent flow, and transition zone. So here I mentioned here. So alternatively, the Moody diagram is used for finding the friction factor for turbulent flow, especially the friction factor is present in the vertical axis, primary axis. In the secondary vertical axis, the relative pipe roughness is mentioned in the secondary vertical axis. In the horizontal axis, is mentioned with Reynolds number OBE by B. So by using the Reynolds number value, so for example here I mentioned the 10 power 5 as the Reynolds number, the corresponding value of friction factor for the surface roughness, that is relative roughness of 0.3 is what. So for 10 power 5 Reynolds number, for the corresponding relative roughness 0.03, um, here it is in between the 0.5, 0.06 to 0.0. So 0.055 is an exact answer of value. It's a friction factor. So we will easily identify the friction factor by using the Reynolds number and relative pipe roughness. So Moody diagram is majorly used for this. What are the minor losses in pipeline? Minor losses means due to the changing section, especially entrance and exit losses, sudden expansion, sudden contraction, because of the pipe fittings, walls, and joints. So that will reduce the flow rate or pressure of the flow. So here are various minor losses calculation I have mentioned here. Loss due to sudden expansion. The diagram mentioned the different pressures in the area of cross section. Flow is happening from section 1 to 2. The sudden expansion will take place. So the velocity will definitely change. And formula for finding the expansion and loss is the difference of V1 minus V2 squared by 2G velocity gradient. So loss due to sudden contraction of pipe flow. So due to this contraction, the contraction coefficient will be formed. Due to the vena contracta area, this is mentioned as vena contracta area. The curve shaped space, one that eddy-like space will be formed. So it is called vena contracta. The area of vena contracta. This is we have to calculate by using the by using the formula Cc. Here Kc is the coefficient we have calculated. This is the formula V2 square by 2 into Kc, the formula for sudden contraction. So obstruction means some particle or obstruction is present in the stream of liquid. So we have to calculate that is the dimension of the diameter of that obstruction is small a. The pipe diameter is capital A means a minus a by a. It's nothing but Cc, that is contraction coefficient. So due to the obstruction, we have to substitute for this Cc, we will get the value of HOBH. Next, minor losses calculation for loss of rate due to inlet of the pipe. So V square by 2G, velocity gradient into the loss coefficient K. K for 0.1 for well-rounded inlet. For abrupt pipe inlet, it will be 1. For abrupt pipe inlet, it will be 0.5. So it is short-ended pipe inlet, so it is 0.5. 0.5 V square by 2G. Loss due to exit of the pipe. So if the pipe will be connected with some other tanks or some other reservoirs means, so we have to put it as we should consider the loss of the due to exit loss. We should consider. So KD into V square by 2G, always say the coefficient is 1. So V square 1. Loss due to pipe bend. So due to the L joint, elbow joint, pipe bends are there, so it will reduce the pressure flow. So based on the radius to diameter ratio, so we have to take that KB, bend coefficient KB from the table mentioned there. So similarly for pipe fittings also, the separate data are available based on the length to diameter ratio. So based on the usage of walls or pipe fittings, we have to select the value of KF, this pipe fittings coefficient. So these are the major and minor losses. How can we calculate? How can we find out the major losses? What's the main equation? So here I mentioned the two tanks AB connected with the pipelines having joints and horizontal and vertical pipes. So here see the first loss, inlet loss here HI, and the horizontal pipe along the pipeline. So major loss that will occur, the HF1 friction is lost at pipe 1. Here pipe bending is there, so HFB, and HF2 is there. Again one pipe bend is there, so HB2, and third pipeline is major loss is occurring here during the flow rate, the major loss pipe is in there. So HF3 is there. Finally, the pipe is connected with the tank B, so outlet loss. Right. So it's so completely the summation of all these losses, major and minor loss, that should be equal to the level of the difference of level of water rate and A and B. So this difference. So that's called as capital H. So H is equal to the summation of all the losses. In some conditions, they will neglect the minor losses, or in some conditions, if they want to neglect in real time practical applications, if they want to neglect the major loss, means we can neglect these H of 1, 2, and 3. If they want, they insist to consider only the minor loss, major losses, means we have to neglect all the minor losses like HI, HPD, and H2. So likewise, we have to do this practice. For example, circuits. So one is tank is connected with some ball flow meter, and it's spread out to the speaker outside. Another one diagram mentions the tank to the packed bed. So for branch flow, a number of joints are there and walls are there. So we have to make practice. I hope you understand this concept of major and minor losses in pipeline flow. We will discuss later. We'll see you in the next video. Thank you.